All right, so section 11.7, proportional segments between parallel lines. And you asked for a proof, and you got a proof. So take some time and write a paragraph proof to show that triangle love is similar to triangle MTV. I love my MTV. Have you guys heard that song? It's oldie. So our paragraph proof is based on the given that MT is parallel to LU. We can conclude that angle 1 is congruent to angle 2 and angle 3 congruent to angle 4 by corresponding angles postulate. And from there, use the angle-angle similarity shortcut to conclude that triangle LUV is similar to triangle MTV. So now we have an example problem here. It says separate the figure below into two triangles. Then find x and numerical values for the given ratios. So they give us the diagram, obviously, and they tell us that EC is parallel to AB. They want us to find x, so we have to find x, which is this segment right here, BC. And they want us to find the ratios DE over AE and DC over BC. So the first thing it tells us to do is to separate the figure into two triangles. So we have triangle DEC, and we know DE is 8 and DC is 12. Then we have the bigger triangle, DAB, and we know that DA is 8 plus 16, which is 24, and DB is 12 plus X, but we don't know X yet, right? Now, based off of the previous slide, we proved that since EC is parallel to AB, we know triangle DEC is similar to triangle DAB. So we can set up a proportion and solve for x. So 8 corresponds to 24, so 8 over 24 equals 12 corresponds to 12 plus x, so 12 over 12 plus x. So we go through the algebra of cross multiplying and solving, and we get x equals 24. So if x equals 24, 24 plus 12 is 36 for side DB, right? So now if we write out our ratios, DE over AE, DE over AE is 8 over 16, and DC over BC is 12 over 24, and of course both of those equal 1/2, so they are proportional, right? All right, so on the next slide here, we have a diagram down below, and it says that AC intersects PB and PD proportionally. It says PA over AB equals 8 over 10, and we can see that from the diagram, 8 over 10 right there. And PC over CD equals 12 over 15. Are AC and BD parallel? So what we have here is a protractor. And we take our protractor and we slide it into place to measure our angles. See if this works for me. That angle comes out to be 70, what does that say? That's hard to read. Will that get bigger for me? No. It looks to be about 74 degrees maybe. So let's see. No, it won't let me write that. 74 degrees. If I bring this protractor back over down here now, and I measure the corresponding angle, because I already know that the definition of corresponding angles, and I measure that angle, and it's also going to come out to be 74 degrees. And going way back to understanding parallel lines and corresponding angles, if given corresponding angles that are congruent, then the lines are parallel. So here we, applying that conjecture, we can conclude that AC and BD are indeed parallel. Now, what we've done is we've gone through a few examples here. We've proven that if we've proven, that if MT and LU are parallel, then the triangles are similar. We used the fact that the triangles would be similar to show that the sides would be proportional. And we used the fact that if the sides are proportional, then the angles would be congruent. And so we can put all of this together into what we call the parallel proportionality conjecture. And it states that if a line parallel to one side of a triangle passes through the other two sides, then it divides the other two sides proportionally. That's what we saw in this example. Conversely, if a line cuts two sides of a triangle proportionally, then it is parallel to the third side. And that is what we saw in this example.